Dear students, welcome to Brilliant Qatar. Today in this session, we are going to discuss the sample paper for the term 1 physics. This is part 1 for the sample paper discussion. As you know, this is the first time CBSE is introducing multiple choice questions for the board exam. And there are 7 chapters, as you know, starting from electric charges and fields till alternating current. So there will be a different type of questions, multiple choice questions like case-based question, assertion, reason, direct MCQs. So let us directly go to the questions. As you know, there are 3 sections, section A, section B and section C. And from section A, you have to attend only 20 questions out of 25. Section B, 20 questions from 24. And section C, 5 questions from 6. Okay, so let's go to the questions directly now. So we are starting with section A. This is section A. Look at question number 1. A body is positively charged. It implies that, option A, there is only positive charge in the body. There is a positive as well as negative charge in the body, but the positive charge is more than the negative charge. There is equal positive and negative charges in the body, but the positive charges lie in the outer regions. Negative charges is displaced from its position. Body is positively charged. What is the meaning of charging? You know that all objects are made up of atoms, and the atoms consist of electrons and protons. So every objects are having positive charges and negative charges. See, look at this here. 2 positive charges are there, 2 negative charges are there. Surely we can say it is a neutral body, right? Charge particles are there, but we won't call it as a positively charged body or a negatively charged body because the net charge of this body is 0. For there is a positive charge. To say there is a positive charge, there should be more number of positive charges in the body. Look at this. If there are 3 positive charges and 2 negative charges, then the net charge will be positive. That's the meaning of charging. So if a body is having a negative charge, we are saying a negatively charged body means more number of electrons. Positively charged body means more number of protons. So which option will be correct? There is positive as well as negative charges. Both are there, but positive charge is more than the negative charge. So the answer for this question is, you can see it is option B. More number of positive charge means the body is positively charged. More number of electron means it will be a negatively charged body. Okay. Now let's go to the second question. Look at this. In a region of constant potential, the electric field is uniform, the electric field is 0. The electric field shall necessarily change if a charge is placed outside the region. None of this. You can see that this is a question from the chapter electric potential and capacitance, right? In a region of constant potential. So hope you remember the relation between electric field and potential. What is that relation? Is equal to, electric field is equal to minus dV by dr. Electric field is a negative potential gradient, right? Minus dV by dr. Here it is given that the potential is constant potential. That means V is a constant. So this will become minus d by dr, derivative of a constant. All of us know that derivative of a constant is 0, right? 0. So what is the answer? Electric field, if potential is constant, electric field will be 0. Electric field will be 0. So the answer is option B. Electric field is 0. It's a repeating question. If potential is constant, electric field will be 0. Okay. Now we are going to question number 3. A dielectric slab is inserted between the plates of an isolated charged capacitor. Which of the following quantities remain unchanged? Again a question from the chapter electric potential and capacitor. So this question is from capacitance. You can see that. So what is happening here? A dielectric slab is inserted between the plates of an isolated charged capacitor. Isolated charged capacitor. That means the capacitor is disconnected from the battery. It is isolated. Okay. So in such a capacitor, what they are doing is a dielectric slab is introduced. Look at this. Let it be the plates of the 2 capacitors. Right? So in this capacitor, when a dielectric slab is inserted, you know that if the medium is free, then we have the formula for the capacitance, which is epsilon naught A upon D, right? Epsilon naught A by D. This is the expression for the capacitance of a parallel plate capacitor. You know that. Inside that, in between the plates of that capacitor, a dielectric slab is being introduced. So the capacitance will definitely change. You know that. We will get a new capacitance which is equal to K times the initial capacitance. So K epsilon naught A by D. So the capacitance becomes K times. If dielectric slab is introduced, definitely it will become K times, what is K here? K is the dielectric constant, relative permittivity, right? So capacity will change, right? Now, second thing you have to check, what happened to the energy stored in the capacitor, right? And there is, look at option D, electric field. You know that electric field in a medium is equal to electric field in free space by what? K. So capacitance are changing, electric field is changing, definitely the potential will also be changing, right? Because you know that E is equal to V by D. So since E is changing, there is no change in D, definitely V will change. Okay, so V is changing, potential is changing, and capacity will also change. Energy stored in a capacitor, you know the formula, energy is equal to half CV square, right? So capacitance is changing, potential is changing, so energy will also change. So here in this question, you can see that the one and only factor, it remains same as what? The charge. Because this one you can easily understand, the capacitor is isolated. So there is no source, right? So there is no source to supply more charge. And there is no way for the discharging. It is an isolated capacitor, right? So which factor will remain same means it is the charge on the capacitor. Hope it is clear. So we are going to the next question number 4. Look at this. The electrostatic potential energy of a system of two charges is negative when? Again a question from the chapter electric potential and capacitance. And you can see electrostatic potential energy of a system of two charges. So just recall the formula for electrostatic potential energy. What is it? What is the formula? You know that U is equal to electrostatic potential energy of a system of two charges is 1 by 4 pi epsilon naught into Q1 Q2 by R. This is the formula for electric potential energy. When two charges Q1 and Q2 are separated by a distance R, then the potential energy is this one. Now what they are asking, this potential energy, for it to be negative, negative means this product of the charges should be negative, right? Then only we get the energy of the system as negative. How is it possible? How can you make it? See, for example, if two electrons are there, means both are negative, so the product will be positive. If two positive charges, then the product will be again positive, right? But we need negative product. So that is possible if one is positive and the other is negative, then their product will be negative. That means for the energy of a system to be negative, one charge should be positive and other should be negative. So which option will come? One charge is positive and other is negative, that is option C, right? So answer for the question is C. One charge is positive and the other is negative. Okay, please note that energy, potential energy is negative means there is another simple idea which you can remember here. Potential energy is negative means force will be attractive, and potential energy positive means force will be repulsive. So for there is force to be attractive, definitely there should be unlike charges, right? That means one is positive and other is negative. All right. Okay. So we are going to the next question now. Question number 5. Look at this. A square surface of side L meter in the plane of the paper is placed in a uniform electric field E, volt per meter, acting along the same plane at an angle theta with the horizontal side of the square as shown in the figure. The electric flux linked to the surface in units of volt meter is electric flux. So there is an area given, be careful. Area is given as it is in the plane of the paper. So I'm just showing this is in the plane of the paper. This is our area. Okay. That area we can take it as side is given as L. So definitely the area will be L square since it is a square. Okay. L square is the area. Then placed in a uniform electric field acting along the same plane. That means electric field is in the same plane. Electric field is lying in the same plane, right? Then all of us know that the equation for electric flux is, what is the equation for electric flux? It is E dot A, right? E dot A. That is equal to E A cos theta. E A cos theta. This is the formula for the electric flux. E A cos theta. What is A here? A is area, but vector is area vector, and you know that direction of area vector is perpendicular to the area. So this is the area, right? That means area vector is perpendicular, means it will be either in or out of the plane, right? So that's a very important idea. So the direction of area vector for this square, the square is given in the plane of the paper. That means area vector will be either into the plane of the paper or out of the plane of the paper. Alright, then if you're assuming it is out of the plane of the paper, then what is the angle between electric field and area vector? Clearly it will be 90, right? And that is the value of theta. You know that in this equation, theta is the angle between vector E and vector A. Vector E and vector A means it is the angle between the electric field vector and the area vector, and that is equal to 90 degree. So we get here as EA cos 90. What is cos 90? It is equal to 0. So what is the flux in this case? The flux in this case is 0. Okay. So the answer is option D. So for creating confusion and all, they had given some other angles as well. Look at this. There is a line drawn and a theta angle is given. No need to bother about that. Concentrate on the direction of area vector and direction of electric field. Okay. Clear? So we are going to the next question now. Question number 6. If EA be the electric field strength of a short dipole at a point on its axial line and EE that on the equatorial line at the same distance, then very simple question, direct question, right? Hope you remember the idea, the concept of electric field intensity due to a dipole. Electric field intensity due to a dipole. First one at a point on the axial line, right? So if this is the dipole consisting of two charges minus Q and plus Q, then at a distance R on the axial line, we have an equation E axial is equal to 1 upon 4 pi epsilon naught into what? 2p by r cube, right? 2p by r cube. This is the expression for the electric field intensity at a point on the axial line. You know that. Now, at a point on equatorial line at the same distance. So, this is the equatorial point. It is the perpendicular bisector. And if distance is also r, then what is E equatorial? It is equal to 1 by 4 pi epsilon naught p by r cube. These two are two very important and very familiar results for all of you. Then they are asking what is the relation between EA and EE. Very simple, right? You can see that EA is 2 times EE. 2 times EE. EA is E on axial line is 2 times E on equatorial line. So this is our option B. EA is equal to 2 times EE. Another repeating question. Okay. Right. Now question number 7. On moving a charge of 20 coulomb by 2 centimeter, 2 joule of work is done. Then the potential difference between the points is. On moving a charge of 20 coulomb by 2 centimeter, 2 joule of work is done. Then the potential difference. Again, a very, very simple question. Just recall the idea of electric potential, right? You know that electric potential V is equal to, it is nothing but the work done in bringing a charge, W by Q, right? Q. So here, what is the work? Work is given as 2 joule divided by charge is 20 coulomb. 20 coulomb. So this is equal to 1 by 10. 1 by 10 is equal to 0.1 volt. 0.1 volt. Very simple. You can easily answer just within 10 seconds you can find the answer for this. So you know that in multiple choice exam, time management is very important. So it's easy question you have to make as quick as possible so that you can save time, you can utilize it for the tough questions. Okay. So we are going to the next question number 8. A wire X has a diameter. Wire X has the diameter and half the length of the wire Y of similar material. Wire X has half the diameter and half the length. Okay, right. Wire Y of the same material, the ratio of resistance of X to that of Y is. So here, the important point which you have to be noted is they are similar material. X and Y are similar material. That means if X is copper, Y is also copper. Right. Now let's start with the given data. Look at this. Wire X has half the diameter. That means if you are writing diameter, or diameter is half, means of course the radius will also be half. So radius of, I am writing here, radius of X is half the radius of Y. That means Rx is equal to Ry by 2. This is the first information. Okay, and what is the second information? The wire X has half the diameter and half the length. That means length of X is also half the length of Y. These two are the given information, right? Then the ratio of resistance of X to that of Y. So what is the formula for resistance? You know that R is equal to rho L by A, right? This is the equation for what? Resistance, where you know that rho is the resistivity, L is the length, and A is the area of cross section. So substitute R is equal to rho into L by area is pi R square, right? Pi R square is the area. Okay. Now here you can see that since both of them are made up of same material is same, so rho will be same, there is no change. Pi is always a constant. That means we can write R is proportional to what? L by R square. So if you are starting with resistance of X, R of X will be proportional to what? L of X by R of X the whole square. Similarly, you can write R of Y is equal to L of Y divided by Ry the whole square, right? Now what they are asking, the ratio of resistance of X to that of Y. X to that of Y, that means we have to find Rx by Ry. Resistance of X to resistance of Y. Just substitute it. We can see that it is equal to Lx by Rx square divided by Ly by Ry square. That means multiplied by Ry square divided by Ly. Okay. Now just substitute. What is Lx? Look at this. Lx is given as Ly by 2. Ly by 2 by Rx. Rx is Ry by 2. So Rx square will be Ry square by 4 into what? Ry square by Ly. So this Ry square cancelled. Ly will be cancelled. Look at the result. We are getting 1 by 2 by 1 by 4. That is equal to 4 by 2. 4 by 2 is equal to what? 2. 2 means 2 is to 1. 2 is to 1 is our final answer for this. 2 is to 1. Okay. It's option C is the answer. So this is a bit lengthy question but easy. So please make sure that you are not making any silly mistake if doing this kind of question. Okay. So answer is 2 is to 1. Clear now? Right. So we are going to question number 9. 9. To draw a maximum current from a combination of cells, how should the cells be grouped? To draw maximum current from a combination of cells, how should the cells be grouped? Cells grouping. Okay, you know that cells can be connected in series, you can connect it in parallel. Mixed grouping are there. That means series and parallel together, right? Then they're asking to get maximum current. So which combination is good? To get maximum current, which combination is good? You know that we can't say. We can't say which combination is good. Why? Because it purely depends on the values of internal resistance and external resistance of the cell that we are connecting. Okay, so if external resistance is greater than internal resistance, clearly which combination is good? Series is good. So please note this point. If external resistance is much greater than the internal resistance, to get maximum current, series combination is good. And at the same time, if internal resistance is greater than external resistance, then parallel combination is good. Okay, so please note these 2 points. So what will be the answer for this question? Here they did not say which resistance is big, internal or external. So the answer is, it depends upon the relative values of internal and external resistance. So our answer is, you can see that our answer is option D. Option D is the answer for this question. Okay. So we are going to the next question now. Question number 10. 10. 3 charges, 2q, minus q and minus q are located at the vertices of an equilateral triangle. At the center of the triangle, some data are given like potential is 0, electric field is non-zero. Let's check. So what is happening? 3 charges are there. 2q, minus q and minus q are kept at the corners of an equilateral triangle. So let it be an equilateral triangle. Okay. So 3 charges are kept at the corners of these triangles. What if you listen here? So these are the 3 points we can take. And at one corner there is 2q, then minus q, then minus q. Okay. And at the center, right? Center means here. So we can take the center. If this distance is r, all the distance will be r only. So if you are taking the potential, what is the formula? How can you find the net potential if there are a group of charges are making a system? Then the potential at the center is V is equal to V1 plus V2 plus V3, right? So we can simply add the potentials due to all the charges. So what we get, 1 by 4 pi epsilon naught into the first charge is 2q by r plus minus q by r plus minus q by r. So this r will come out. So what will be the result? Minus q will become minus 2q and there is plus 2q. So definitely potential will be 0. No doubt the potential at the center of this triangle, at the centroid of this triangle will be 0. Now what we need to check? What about the electric field? Will it be 0 or not? Okay, electric field, you can just check what we need. We don't need to find the magnitude. They are not asking what is the magnitude of electric field here. We just want to check whether that field is 0 or not. 0 or not. How can we check it? For it to be 0, all the fields, that vector sum of all fields should be 0 as per superposition principle, right? For the net field to be 0, the vector sum of all fields, I mean fields due to individual charges, has to be 0. That we can check. How can you check it? Check the direction. That will be easy. Okay, electric field is the force experienced by a unit positive charge. So you can simply assume we are keeping a plus 1 coulomb charge here, right? Plus 1 coulomb charge here. So this one is positive and plus 2q. This is also a positive. So positive repulsion. So field will be in this direction. Due to this 2q charge, there will be field in this way. I'm just marking E1. E1. Similarly, due to this is a negative charge and at the middle there is a positive charge. So that unit positive charge will be experiencing an attraction. So this is a field due to that. E2 I am marking. Similarly, this is again a negative charge and this is positive. So it will also be attractive. So what we are getting is the net effect of field will be something like vector sum of 3 fields acting in this direction, right? So there are 3 fields. Look at this. This is E1, this is E2, this is E3. You know that there is no field to cancel these, right? In the opposite direction, you can't see anything. So definitely the resultant electric field will not be 0. In this case, there will be some field. So potential is 0, but field is not 0. Potential is 0, field is not 0. Look at that. It is option B. B is the correct answer for this question. Okay, B is the correct answer. Right? I'm going to the next question number 11. I think it's very clear. This is the idea which you have to use. Question number 11. In a region, steady and uniform electric and magnetic fields are present. These two fields are parallel to each other. A charged particle is released from rest in this region. The path of the particle will be. So it's like, it's not a question from a single chapter. We can see the idea of electric field and magnetic field is used here. So read the question once again. In a region, steady and uniform electric and magnetic fields are present. So there is a steady electric field. We start with electric field. Okay, after that we will check about the magnetic field. Look at this. Let it be the electric field, and you can see the field is directed from left to right. Okay, we are just taking an electric field which is directed from left to right. All of us know that direction of field is from positive charge to negative, starting from positive and ends at negative. Okay. In region, steady and uniform electric and magnetic fields are present. These two fields are parallel to each other. A charged particle is released from rest. Okay, so I'm just keeping a charged particle. Any charged particle. It can be a positive particle or a negative particle. So here I am considering it as a positive particle. So plus Q I am keeping here. Okay, plus Q. Assume it is a positive. So definitely this positive will be experiencing a force. We have the formula for the force. What is it? F is equal to Q times E. This is electric force. Electric force on a charged particle, QE, right? QE. And what will be the direction of that force? See, force positive is here, so positive will be repelled and it will be experiencing force in this direction. So as a result, what will happen? This charge will be moving. The charge will be moving in the direction of electric field. Straight line path only. It will follow a straight line path. Got it? So due to the electric field, what is happening here means the charge is moving in a straight line path. Okay. And then what is happening? There is a magnetic field as well. In the same region, there is a magnetic field. But it is given that magnetic field and electric fields are parallel. So if this is electric field and this is magnetic field. Okay. Now what we can understand, this charge, it's already in motion. It started the motion due to electric field, right? it will experience a force due to the magnetic field as well. So we have to write the equation for that magnetic force, that is Lorentz force. You know that F is equal to FB is equal to Q into V cross B, right? This is the formula for the magnetic Lorentz force. It is equal to QVB sine theta. QVB sine theta, where theta is the angle between the velocity and the magnetic field. Okay, it's going towards right. Magnetic field is also acting in the same direction. So tell me, what is the angle between velocity and magnetic field? They are parallel, right? So theta value is equal to 0. So what we get? QVB sine 0. Sine 0 is equal to 0. So the magnetic force on this particle will be 0. So there is no magnetic force acting on this particle. Only electric force is there. And due to that electric field, we already got an idea that the charge is moving straight line, right? Straight line. There is no magnetic force. So what is the answer for this question? It is straight line. Okay, so be careful. We have applied both the ideas, electric force and magnetic force, and checking the directions. Got it? Yes. Now we are going into the next question, number 12. 12th question. Look at this. A and B are 2 points in an electric field. If the work done in carrying 4 coulomb of electric charge from A to B is 16 joule, the potential difference between A and B is. Again, a simple question. We have already discussed this kind of question. Total work, potential difference, right? Potential difference is equal to work done by charge. Okay, so V between A and B is equal to work done to move a charge from A to B by the magnitude of the charge. Very simple question. So what is the work here given? Work is 16 joule. Work is 16 joule, right? 16 divided by charge 4 coulomb. Okay, so 16 by 4 will be 4 volt. Very simple question. Answer is option C, right? Option C. Okay, I hope there is no doubt about this. Very simple calculation of potential difference. Okay, so I'm going to the next question, number 13. Yes, direct question repeating type. What is it? Look at this. Kirchhoff's first law, that is sigma I is equal to 0 at a junction, deals with the conservation of sigma I equal to 0, Kirchhoff's first rule, Kirchhoff's junction rule, Kirchhoff's current rule. What does it state? It states that the algebraic sum of currents meeting a junction is 0, right? The algebraic sum of currents meeting a junction is 0, or total current coming to a junction is equal to the total current leaving the junction. So what is the idea in this? Which one is conserved? Current is conserved, current is flow of charge. So basically charge is conserved, right? Charge is conserved. So normally this question is asking, a question may come either from Kirchhoff's first rule or second rule, junction rule or loop rule. So junction rule is, of course, it deals with the conservation of charge, and loop rule is conservation of energy, right? It's saying that the voltage is constant. So be careful, don't be confused. Junction rule means conservation of charge, loop rule means conservation of energy. Okay, right. Question number 14. A parallel plate capacitor is charged by connecting to a battery. Now the distance between the plates of the capacitor is increased. Which of the following remain constant? Okay, again a tricky question. Look at this. There is a capacitor. Okay, you can take its capacitance as what? C. It is connected to a battery. That means we are offering a potential here, right? And you can assume that potential is V. Okay, so capacitance, and it's connected to a battery. Battery is still there, and after that what they are doing? They are changing the distance. So distance is increased, but still the battery is there. Please understand, battery is there. So when you are increasing the plate distance, so definitely distance D changes, right? So when D changes, what happens? Capacity will change. But here what the question is, which of the following remains constant? It's a very simple question, because battery is still there. We are offering a potential V. Same battery is there. So there is no change in the potential, right? Since the battery is still there, you can't change the potential of the capacitance. They are connected in parallel. So whichever voltage you are applying, the applied voltage will be there as the voltage across the capacitor. So in this question, the quantity which remains same is what? Potential difference between the plates of the capacitor. That's the right answer. Potential difference. Students, please note that if you are disconnecting the battery, it will change. Potential will change. We have already discussed a question like that in the case of an isolated capacitor, right? But this one, battery is there, so definitely the potential will also be the same. Okay, right. Question number 15. A particle of mass m and a charge q enters a magnetic field perpendicularly with a velocity v. The radius of the circular path described by it will be. Important, easy. Listen here. Particle of mass m and charge q enters a magnetic field, right? Based on Lorentz force, you know that. What is the equation for force on a charged particle moving in a magnetic field? F is equal to qv cross b, that is qvb sine theta, right? Sine theta. qvb sine theta. Okay, so perpendicular means theta value will be 90, so we get qvb sine 90. Sine 90 is 1, so F is equal to what? qvb. So this much force is there on the particle. And definitely you know that the path of a particle when it is moving in a magnetic field and it is entering in a magnetic field perpendicular to it, it follows a circular path, right? So this charge will be definitely following a circular path. Now what they're asking, the radius of the circular path is, right? Okay, so take the radius as r. We have to find the value of r. This charge is experiencing this much force and it is moving with a velocity v, right? V. What's the idea? All of you know that one of the basic idea in physics, for circular motion, the body needs a centripetal force, right? Without centripetal force, the body can't move in a circular path. So here you just think, who will provide the centripetal force, right? From where this charged particle will get the centripetal force? That is from the Lorentz force. So you can just use the idea, centripetal force. What is the formula for centripetal force? It is mv square by r. It is provided by the Lorentz force. We already got the Lorentz force as qvb. This is the idea. Centripetal force is provided by the magnetic Lorentz force. One v will be cancelled. We have to find the value of r. So r is equal to what we can see. It is mv by qb. Look at that. mv by qb. It's option D, right? mv divided by qb. So that's the answer for the question. Very simple. Basic idea is centripetal force is provided by magnetic Lorentz force. Okay. I'm going to the next. Magnetic field intensity at the center of a coil of 50 turns, radius of 0.5 meter and carrying current 2 ampere. It's a direct numerical, right? Magnetic field intensity at the center. Magnetic field intensity at the center of a circular coil. Number of turns is given, radius is given, current is given. So if this is a circular coil, okay, it is carrying some current. This is the center O. Radius you can take R. Carrying current I. Number of turns is N. What is the formula for the magnetic field at the center of the circular coil? You know that it's B is equal to mu naught Ni by 2R. This is the expression, right? Mu naught Ni by 2R. We can just substitute. Mu naught value is 4 pi into 10 to the power minus 7. Number of turns is given as 50. Current I is given as 2 ampere. Divided by 2 into radius is 0.5. Okay, so this will become 4 pi into 10 to the power minus 7. 50 into 2 will be 100. 2 into 0.5 will be 1. So this is equal to 4 into pi, 3.14 into 10 to the power minus 5, right? Sorry, minus 5, not 15. Minus 7 into 100 will become minus 5. Okay, so this 4 into 3 will be 12. So answer will be 12 point something into 10 to the power minus 5. That is equal to 1.2 something into 10 to the power minus 4. Yes, 1.25. So we can approximate, no need to find the exact number. So it is 1.25 into 10 to the power minus 4 Tesla is the answer. Option B, 1.25 into 10 to the power minus 4 Tesla. Okay, very simple. So we have to recall the formula. Okay, you have to study all the formulas from all the chapters. Okay, in this chapter, you know that moving charges and magnetism, many formulas are there. Don't be confused. Use the proper formula and do it. Okay, next. 17. A current carrying conductor placed in a magnetic field experiences a maximum force when angle between current and magnetic field is. Again, a question from moving charges and magnetism, right? A current carrying conductor placed in a magnetic field experiences maximum force when the angle between current. So what is the formula for force acting on a current carrying conductor? F is equal to I L cross B, right? force on a current carrying conductor in a magnetic field, I, L cross B. What is L? L is the length and B is the magnetic field. So this can be written as I, L, B sine theta. Sine theta. This is the equation for the, you know that, force acting on a current carrying conductor kept in a magnetic field. Now what they are asking is, experiences maximum force when the angle between current and magnetic field is. So for this force to be maximum, what should be the value of theta? You know that for this force to be maximum, this sine function has to be maximum. Sine theta has to be maximum. What is the maximum value of sine theta? Maximum value of sine function is 1, right? And you know that to get sine theta is 1, theta has to be 90 degree, right? 90 means pi by 2. Sine 90 is 1, right? Okay, so pi by 2 is the answer for this question. Pi by 2, option B. Option B is the answer for our 17th question. Clear? Yeah. Next. Number 18. A transformer reduces 220 volt to 11 volt. The primary draws 5 ampere of current and secondary 90 ampere. The efficiency of transformer is transformer. A question from the chapter alternating current, right? Transformer, and this is about the efficiency of a transformer, right? What does mean by efficiency? Efficiency of any device is the ratio of output power to the input power, right? So the same formula only using here also. Efficiency of a transformer is equal to P out by P in. This is the equation for efficiency, right? Now, how can we find the output power? You know that in a transformer, there are two coils, right? One, the coil through which the input is given, that is called the primary coil, and the other is a secondary coil. So, the current through the primary, we can represent it by IP, and current through secondary is what? IS. Voltage across primary is VP, and voltage across secondary is VS, right? VS. So, what is the formula for power? Power is V into I, right? V into I. So, definitely the output power will be what? VS into IS, and input power will be VP into IP. VP into IP. So, what is VS? Secondary voltage. It's given 11 volt, right? All of you look at this. 220 is the primary voltage, 11 volt is the secondary voltage. 5 ampere is input current, primary current, and 90 ampere is output. So VS V secondary is 11 into secondary current is 90. VP primary 220 into current in secondary 5. Okay, so what we get here, 11 by 22 will become 1 by 2. So 9 by 2 into 5, 10. So 0.9. 0.9 is efficiency, but if they are asking it in percentage, so into 100%. 0.9 into 100% will be equal to what? 90%. 90% is the efficiency. Very simple question. Okay, so please don't make any silly mistake here. Efficiency formula is output power by input power. Okay, VS IS by VP IP. So the answer is 90%. See, option D. Okay, next question number 19. Which of the following graph represents the correct variation of inductive reactance with frequency? Inductive reactance with frequency. Question from the chapter alternating current, right? Inductive reactance. Tell me, what is mean by inductive reactance? The resistance offered by an inductor, right, is called what? Inductive reactance. And what is the equation for inductive reactance? X, inductive reactance is denoted by XL, right? XL equal to what? 2 pi F. 2 pi F. Okay, so from this you can see that where F is the frequency, clearly XL is directly proportional to the frequency, right? Directly proportional. That's it. We got the answer. Out of this graph, which graph is showing a directly proportional relation? Directly proportional means you know that the graph will be a straight line with a positive slope, right? So which one? The first one. As the frequency increases, inductive reactance is also increases. That means answer is option B, right? You can see the graph is a straight line with a positive slope. So B is the correct option for this question. Okay, now in the same time, like if they're asking about capacitive reactance, then what will be the shape of the graph? So you know that capacitive reactance is 1 by C omega. Sorry, please not here. XL is L into omega, right? So L into 2 pi f. So anyway, XL is directly proportional to f. Answer will be same. So here it is 1 by c into what? 2 pi f. So what you can see, XC is inversely proportional to frequency. So if they are asking capacitive reactance, the shape of the graph will be inversely proportional relation will be something like this. So you can XC and frequency will be like this. Okay, it will not be a straight line because it is inversely proportional. So read the question carefully. For inductive reactance, B is right answer. If they are asking capacitive, this one. Okay, right. Next question. Question number 20. A metal ring is held horizontally and a bar magnet is dropped through the ring with its length along the axis of the ring. The acceleration of the falling magnet is. It's again a repeat type question from Lenz's law. It's actually from EMI. There is a ring. A metal ring is held horizontally and a bar magnet is dropped through the ring. So through this ring, a bar magnet is dropped. North, south. It's a length along the axis. Okay, it is dropped like this. Then what they're asking, what will be the acceleration of the magnet? So you just leave this ring. If you are dropping a body, any body, if you are dropping, what will be its acceleration? Its acceleration will be equal to the acceleration due to gravity, right? Gravity, it's g. But in this case, it will be something different. You know, what is the reason? Because this is a metallic ring and a magnet. So when a magnet is moving through a metallic ring, definitely for the ring, the flux will be changing, right? So EMF will be induced in it. Current will be induced in it. So as per the Lenz's law, the direction of induced EMF is such that it opposes the cause which produces it, right? So what is the reason for inducing EMF here? The downward movement of the magnet. So this induced EMF will try to oppose it. That means there will be an opposing force. If opposing force is there means we can't consider it as a free fall. There is an opposition, right? So definitely acceleration will not be equal to the acceleration of a freely falling body. Since there is an opposition, it will be less than the acceleration due to gravity. Less than the acceleration due to gravity. That means the answer is option B, less than G. Now, we are going to the next question number 21. Two solenoids of same cross-sectional area have their length and number of turns in the ratio 1:2 both. The ratio of self-inductance of two solenoids is. Okay, very simple question. Look at the question. Two solenoids are there. Cross-sectional area is same. Length and number of turns. So, length are in the ratio 1:2. That means L1 by L2. L1 by L2 is equal to 1/2. Okay. And number of turns ratio. That means N1 by N2. Total number of turns. It's equal to 1/2. Then, the ratio of self-inductance. Okay, self-inductance. What is the formula for self-inductance? L is equal to mu naught N square A by L. Mu naught N square A by L. So L1 will be what? Mu naught N1 square A by L1. L2 will be mu naught N2 square A by L2. Then L1 by L2, right? That's what we have to find. So what we get? Mu naught cancel. A get cancelled. So we get N1 square by L1 divided by N2 square by L2. That is equal to N1 square by L1 into L2 by N2 square, right? That is N1 by N2 the whole square into L2 by L1. What is N1 by N2? N1 by N2 is 1/2. So it is 1/2 the whole square into L2 by N1. L1 by L2 is 1/2. So L2 by L1 will be 2. So we get 1/4 into 2. That is equal to 1/2. 1/2 means 1:2, right? 1:2. This is the result. So here, students, please note that it is given total number of turns. We have another formula for the self-inductance. That is L is equal to what? Mu naught N square AL. If you are using this formula, it will lead to a wrong answer because here N is what? Number of turns per unit length. Here it is given the ratio of total number of turns. So please don't be confused. You have to use the proper formula for it. Okay. Next. Question number 22. Two coils are placed close to each other. The mutual inductance of the pair of coil depends upon. Mutual inductance of the pair of coil depends upon the rate at which the current are changing in the two coils, relative position and orientation of the two coils, the material of the wires of the coil, the currents in the two coils. Listen, mutual induction. For there is mutual induction, there will be a change in flux in the first coil. Due to that, an EMF is induced in the neighboring coil, right? So if you are changing the position of the two coils, definitely the mutual inductance will change. If the second coil is far away, you know that there won't be any mutual induction, even though there is change in current in the first, right? So clearly it depends on the relative position and orientation. Okay, relative position and orientation of the two coils. So B is our right answer. Okay, next. According to Faraday's law of electromagnetic induction. Direct question. The statement only they are asking. What is, or state Faraday's law of electromagnetic induction. What is it? As per Faraday's second law, you know that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux, right? Rate of change of magnetic flux. Very simple question. Directly they are asking. Okay. Like that, they can ask other laws as well. Look at the first one. Option A is actually Lenz's law, right? So please don't be confused. This is Faraday's law of electromagnetic induction. So I think I can go to the next. Question number 24. With the increase in frequency of AC supply, the impedance of an LCR circuit is important question. Frequency and impedance, right? You know that in an LCR circuit, the current will be maximum at resonance, right? So at resonance frequency, here look at the graph. Hope you remember the resonance curve. If you are drawing the graph between current and frequency, the shape of the graph is something like this. This is the resonance curve, and you know that at resonance frequency FR, the current is maximum, right? So current is maximum means impedance is minimum. That means if you are drawing the graph between impedance and frequency, it will be something like this, right? That means the impedance is minimum at resonance frequency. So look at the graph for impedance. You can see that as the frequency increases, you can see that the impedance decreases, becomes minimum, and then increases. That is the answer. Okay, impedance decreases, becomes minimum, and increases. That means the answer for this question is D. Okay. Now we can go to next. Question number 25. In a transformer, the number of turns in the primary coil are 140 and that in the secondary coil are 280. If current in primary coil is 4 ampere, then that in the secondary coil is again a simple question from transformer. Just recall the formula and substitute. Very simple here. In a transformer, number of turns in primary, NP is 140 and number of turns in secondary, NS is 280. If the current in primary coil is 4 ampere, I in primary is 4 ampere, then the current in the secondary coil is 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 equal to what? This is the question, right? So if you can recall the number of, transformer ratio, what is it? NS by NP is equal to IP by IS. NS by NP is equal to IP by IS. So we have to find IS value. So IS is equal to what? IP into NP by NS, right? IP into NP by NS. What is IP here? 4 ampere. NP is 140. NS is 280, right? So 14 by 2 will become 1 by 2. 4 into 1 by 2 is 2. So the answer is 2 ampere. 2 ampere. Option B. Okay. Right. So the answer is option B, 2 ampere. Okay. So 25 questions of this paper has been completed. So this is our part 1. We'll be continuing the discussion in our part 2 video. Okay. Thank you very much all of you for watching. Keep watching. Thank you. Bye.